What's good everyone, you're back with your boy Jono for another quick math lesson. Today we're going to look at index laws, but only when there's something to the power of zero. This doesn't mean that it has no power, but there's a special case which makes it really easy. Just like with multiplication, when any number multiplied by zero is zero, this also has a really easy trick to save you heaps of work. The first thing we're going to do is prove this with kind of just a pattern recognition, just so we can see kind of how we're moving along. So this first one here, we've got 3 to the power of 4, and that's equal to 81. So 3 times 3 times 3 times 3 is 81. So that means to turn 3 to the power of 4 to 3 to the power of 3, that last times 3 here has to disappear. The way that I get rid of that is I must divide by 3. So 81 turning into 3 to the power of 3, I have to divide by 3, which is equal to 27. Now to do this again, 3 squared, 3 times 3 I know is 9, but another way to look at it is that 3 to the power of 3 is being divided by 3 again. So this is equal to 9. 3 to the power of 1, or 3 just by itself, is obviously equal to 3. 9 to 3, again, is divided by 3. So we can see here that moving down these answers, all I'm doing each time is dividing by 3. So it makes sense that 3 to the power of 0 would be the exact same hop. So if I divide this by 3, my answer there is 1. So what I'm saying is that following this pattern, any base to the power of 0 is equal to 1. We're going to have a look at another proof just to make sure we've got it locked in. So if I had 4 to the power of 3 divided by itself, I would have 4 times 4 times 4 divided by 4 times 4 times 4. We know that anything divided by itself is 1, but we're just going to cancel out all these times 4s to see what's left over. So cancel, 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 cancel. Nothing left on the top or the bottom, so that means it is 1. Because 4 to the power of 3 divided by 4 to the power of 3, I would minus those. That means that 4 to the power of 0 is equal to 1. So my overall rule is that any time I've got any base to the power of 0, it equals 1. 20 to the power of 0, 1. X to the power of 0, 1. Don't have to do any work for these ones. The only time we've got to be careful with these is when we've got two terms. The power of 0 only goes to the letter that is directly next to it. So whichever's shoulder the 0 is sitting on, that turns into 1, but nothing else in the equation does. So if I'm struggling with this, what I'll do either in my calculator or in my working is where I see a term to the power of 0, I'll put bracket 1 bracket just to make sure I'm not using that 0 across multiple terms. So for this example here, I've got 6 plus 6 to the 0, which if I rewrite becomes 6, because I've done nothing to that, plus 6 to the power of 0 is bracket 1 bracket, which is equal to 7. This next example here is where a lot of my students make mistakes. The 0 here is only with the x, not with that 7. So what I'm going to do is I'll rewrite it. The 7 stays exactly the same, and x to the power of 0 becomes bracket 1 bracket. So that means 7 is multiplied by 1, which is equal to 7. Just make sure we're on top of that, and I would highly recommend rewriting that line of working with the brackets, because you can just then chuck it into calculator and not have to worry about it. I hope this was helpful, and I'll see you guys later.